Hello everyone, today we are going to discuss origin of X-rays. In this we are going to discuss characteristics of spectra. This is also called as line spectra because which characterize the material which is connected or which is attached to the anode. So in last videos we have seen that the discovery of X-rays and production of X-rays. The link of that videos we have given in below description box. So origin of X-rays. We have seen that in modern Coolidge tube or Roentgen discharge tube, the high velocity electrons which having the high kinetic energy strike on a target material of an anode. Most of the kinetic energy of the electron goes into the heating of the target anode. So here what will happen? The most of the kinetic energy is waste in the heating of the target material and only small amount of kinetic energy are used for the production of the X-rays. This small amount of kinetic energy absorbed by the target atoms, that is the which is present on the screen of the anode and which produce the X-rays. This loss of kinetic energy for production of X-rays, this absorbed amount of energy which is used for the production of X-rays. This loss of kinetic energy are utilized in two ways. This loss of kinetic energy is utilized in two ways for production of X-rays, that is the definite wavelength X-rays, that is called as characteristic spectra or line spectra, and another is the X-rays of continuous varying wavelength, that is the continuous spectra. So here in this video we are going to discuss this definite wavelength X-rays or characteristics X-rays. So here what will happen? So from cathode, that is due to the thermonic emission, that cathode emitting the electrons and there apply the high potential difference. Due to the high potential difference, this electron is accelerated toward the anode and which acquire the very high kinetic energy. So here what will happen? So this electron acquire the velocity, that is the 1/10 of the velocity of light, and this electron having sufficient energy to knock out the K cell electron. This is the K cell, this is the L cell, this is the M cell. So this electron which having the very high kinetic energy, that's why it can penetrate inside the atom and it will going near to the innermost cell and knock out the electron of the innermost K cell electron. And here, so this electron coming with very high kinetic energy, it will collide on the K cell electron and this K cell electron also going outside. So here creating the vacancy. So here creating a vacancy and this vacancy is filled by nearby electron. So L cell electron is filled this vacancy and here is creating the vacancy. So energy difference between this K cell and L cell, there is creating the X-rays which having the frequency in the order of 10 to the power 18 hertz. So here, so this frequency, this we can calculate it in this way. So H is the Planck constant, nu1 is the frequency difference between frequency which is the energy difference between K cell and L cell. So frequency 1 is equal to, we can calculate Ek minus El divided by H. So this is the frequency V1. If the electron bombard or penetrate and knock out the electron from K cell and this vacancy is filled rather than this L cell electron, so this vacancy is filled by rather than this L cell electron. So here this electron will collide on a K cell electron, this will knock out and this will going outside, here creating the vacancy, and this vacancy is filled rather than this L cell electron. So this vacancy is filled from the M cell electron and here is creating the vacancy. So energy difference between this K cell and this M cell is large. So this H nu 2 is equal to Ek minus Em. So here is getting the more energy difference. So nu 2 is equal to, we can write Ek minus Em divided by H. So here this nu 2 is greater as compared to the nu 1 when the electron is falling from this L cell to M cell. So this energy difference is small and we will get the small frequency as compared to this K to M cell when the electron is falling from M to K cell. So here the energy difference, we will get the X-ray photon which having the frequency that is nu2, which is greater than the frequency of nu1. If the electron is coming which having only sufficient energy to knock out only L cell electron, not a K cell electron, which having sufficient energy only it can knock out the L cell electron. So here it will knock out the L cell electron, here creating the vacancy, and this vacancy is filled by nearby orbit, that is M orbit, and in this way the difference between these two energy, this EL minus EM, that is H nu is equal to EL minus EM. So nu is equal to EL minus EM divided by H. So here creating the photon of X-rays, and in this way we can calculate the frequency. So in this way, this is the L cell, this is the M, this is the K cell, L cell, M cell, N cell, O cell. So here what will happen if the electron is falling on K cells from this L to M, L to K, M to K, N to K, and this O to K, then we will get the series. That series is called as the K series. Similarly, for the electron is jumping from nearby higher to L cell, from M to L, N to L, O to L. So this series is called as L series, and this is the M series. So from N to M and O to M. So this is the M series. So here what will happen? So this first line of K series is called alpha 1 or K alpha or K1. Second is K beta or K2. Third is K gamma or K3, or this 4 K4. So here what will happen? Here is the nu4. So this is the nu4 frequency. So here from O to K, this energy difference is very large, so that's why this nu4 is larger frequency as compared to this EL to E minus EK difference. So this K alpha having the frequency nu1, so nu1 is smaller as compared to nu4. Nu4 is greater as compared to the nu1. So nu4 which having larger frequency, larger energy difference. This nu3 is larger energy as compared to this, or smaller as compared to this. So similarly in this way. So if the frequency is large, wavelength is small. If the frequency is large, wavelength is small. If the frequency is small, wavelength is large. So for this line, frequency is small but wavelength is large, and for this, frequency is large and wavelength is small. So in this way we will get this. If the electron is falling from K line, so this is the K alpha, K beta, K gamma, or so on. And similarly for L alpha, L beta, L gamma, similarly M alpha, M beta. Sorry, this is the series limit of L series. This is the series limit of M series, and this is the series limit of K series. This electron will falling from infinity to K line, and this electron will falling from infinity to L line. This electron falling from infinity to M line. So this is the series limit for M, this is series limit for L, this is series limit for K. In this electronic transition, we get the K, L, M, etc. series line spectra, which is characterized of the particular material. So in this way we can characterize the material. So these lines we will get the characteristic spectra. This energy difference is radiated in the form of X-rays. So energy difference which will radiate the X-rays, with definite wavelength. So if the electron jumping from this to this, it will radiate X-ray which having the certain definite frequency or wavelength. This wavelength depends on the target material, and this spectra we will get on the basis of that target material. So every target material having the different this type of characteristic spectra. So this X-ray spectra consists a sharp line. This sharp line, due to this, it characterize the material. So due to these lines we can characterize the material, because different material having different lines, different frequency lines. So this X-ray spectra is known as line spectra or characteristics spectra. So here what will happen in X-ray spectra, we have seen that the outer cell electron will fall into the inner orbits, and if the electron, that is the valence electron, jumping from outermost orbit, outermost cell to the inner cells produce the radiation of visible light, and it emit the radiation, that radiation having the less energy as compared to the X-rays. If the valence electrons jumps from outermost cell to inner cells, at that time it emits the radiation, and that radiation is the visible light radiation, not a X-ray radiation. So in this way we have discussed the characteristic spectra of the X-rays. If you like this video, please like, comment and share with your friend. Thank you for watching this video till to end.